Bismillahirrahmanirrahim. Today, inshallah, we shall learn some basic terms about circles. Here you see a circle before you. A circle is a set of all points that are equidistant or the same distance from a point called the center of the circle. So here's the center of this particular circle. And a circle itself is a set of all points, like here, that are equidistant or the same distance from this particular center. And this distance from the center to all the points that are on the circle, that's called the radius. So the radius is the distance from the center to any particular point that's on the circle. Now, one thing that you must appreciate, the center itself over here is not part of the circle. The circle is all the collection of points. Center is just a defining feature of a circle. The point that's called the center point is actually not part of the circle. Now, we can label the centers, and in general, if you recall, in geometry, we label points with capital letters, so we can call this center, center O. And this circle would be known as circle O. Now, that's always not a particularly good name for circles because it looks like a zero. You can have a circle with circle A, for example. So, and the way you write that is symbolically. For example, you write triangles like that, right? So the way you write circle in geometry is you write a circle, you put a little dot in it, and like this. So this would be read as circle A. And this, if you wanted to write this would be circle O. So the centers and points on the circles are typically labeled with capital letters like all points are. And the distance from the center to any particular point that's on the circle is called the radius. Now, let's label some of these points. Let's call this point A over here on the circle, and let's call this point B over here, and we can call this point over here point C. As you can see, I have labeled the point with capital letters because by convention, points are named using capital letters. And here's a point that's not on the circle, but it is outside the circle like this. This is point D. And here's a point that's on the inside of the circle like this. So point D over here is said to be exterior to the circle, and point E here is said to be in the interior of the circle. So there are exterior points and there are interior points, and of course there are points that are part of the circle or on the circle, as you see here. So point A, B, and C are part of the circle or on the circle, and point D is exterior to the circle, and point E is in the interior of the circle. Now, two circles are said to be congruent. For example, circle here, circle O, is said to be congruent to another circle, let's call that circle P, if their radii are congruent. That is, if circle O is congruent to circle P, then the radius of circle O will be equal to the radius of circle P. So two circles are congruent if their radii are congruent. Now, let's take the circle P and let's pick out a couple of points on circle P like this. Let's call this one M, and let's call this point N. And if you were to connect these 2 points like this, this particular segment is called a chord. So a chord is a segment that connects 2 points that are on the circle. Let me draw another chord here in this particular circle, circle P. Here's another chord that goes like this. Now, even from this drawing, you can tell these chords are of various lengths. They're not the same length. The distance that a chord is from the center kind of determines its length, doesn't it? Let me try to draw another chord over here. Let's say from here to over here. And these are of different lengths. So the length of a chord obviously depends on how far away it is kind of seemingly from the center. The way you would measure the distance of the chord from the center is by drawing a perpendicular segment from the center to the chord like this. So you would draw a segment like this that is perpendicular to the chord from the center. So this would be perpendicular. The reason for that is, in fact, for any particular point that's from outside of the line, the distance from the point to the line is the perpendicular distance. So if you want to know how far this point is from this particular line, you don't calculate that distance or that distance or that distance, right? You would calculate the closest distance or the perpendicular distance. So the distance from a point to any particular line is the perpendicular distance from the point to that line. So the same way, the distance from the center to the chord is the perpendicular distance from the point to the chord. So in this case, from point P to this particular chord, you can name this point, I don't know, you just call that point D. So that would be the distance from point P to D. So the measure of the segment PD would be how far the chord would be from the center of the circle P. Okay, and for this particular, the yellow chord over here, you would similarly draw a perpendicular line like this, and this distance that you would measure over here, let's call that D2, and let's call that D1. That would be the distance of the chord from the center of the circle, center P. Now, a circle has infinite number of points, correct? Because there are infinite number of points you can just pick out from the circle. So therefore, it will have infinite potential, infinite number of chords that you can generate. So let me just draw out a few for you. Here's one, and from the same point, maybe there's another one. Here's another chord. Here's another chord. Here's another chord. Here's another chord. But then I'm going to draw. Well, I just have to correct myself, because the last chord that I drew, this is not a chord because it kind of goes out of there. Chord is from the 2 points from that connect the circle like this. Okay, so the chord is a segment that connects 2 points that are on the circle, so it can't like go out like that. Okay, so anyway, so this is on the circle, but then I'm going to draw a very special chord, and this particular chord is going to be special, you'll see, because why? Because it will go through the center. And also there are infinite number of such chords, because you can draw a whole bunch of chords that go through the center like this. Here's another one that's going through there. Here's like another one that's going through there, correct? But these nevertheless are very special chords, because the chords that go through the center, that's the diameter of a circle. Here's the diameter of a circle. Now I'm going to draw one of the radius of the circle right here. One of the radii, so that's the radius over here. So the radius is the distance from the center to any particular point, and the diameter is distance from one of the points to another point of the circle. It's a chord, but it goes through the center of the circle. Now imagine this point over here and this point over here. From here to here is of course radius, and from here to here is another radius, right? Because this is a point on the circle here, and that's the center, and this is a point on the circle, that's the center. So as you can see, a diameter will have 2 radii. So we can say the diameter of a circle, that we can just call that D, and it's going to be 2 times the length of the radius. So 2 radii make up the diameter, so to speak. Now, while we're at it, I'm just going to mention the formulas for the area and the circumference of the circle. The formula for the circumference of the circle, or the perimeter of a circle, so to speak, or the length that goes all the way around. If you were to take a string and kind of like put it around the waist of the circle, and then you measure the string out, that's the circumference of the circle. So the formula for the circumference of the circle, if you remember, is 2 times pi times r, or this is 2r, which is the diameter, or pi times the diameter, like this. I don't know, for whatever reason I use a capital D for diameter. It's kind of stuck with me, but you can use a lowercase d if you wanted to. But so that's the formula for the circumference, or the perimeter, so to speak, of a circle. 2 times pi times r. And if you recall the formula for the area of the circle, like how much paint you would need in order to like cover the circles with paint, so to speak. The formula for the area is pi times r squared. So pi r squared is the formula for the area, and circumference is 2 times pi times r, or pi times diameter. Now, these are simple formulas, but for whatever reason, some students have the hardest time trying to remember these. I don't know why, but just circumference is 2 pi r, area is pi r squared. Basic stuff, you must know it. Okay, continuing with some more basic terminology, I have circle O over here again, and I have a chord here, chord AB, which is a segment that connects these 2 points that are on the circle, point A and point B. There's another term, and that's like for a line that goes through the circle, like this. So now, this is not a segment, this is a line that goes kind of through and through the circle. Let's call this point, that intersection here, point C and point D. And you can call this line S, for example. Let's call that line S. Now this line is called a secant. A secant is a line that goes through and intersects the circle at 2 points, exactly at 2 points. So a secant is a line that intersects the circle at exactly 2 points. Now compare that to this particular line that I'm going to draw next, which is right over here. Now this line is a line that intersects the circle at exactly 1 point, and this point is called the point of tangency right here. So this line is called a tangent, as going off on a tangent. And a tangent line intersects the circle at only 1 point. A secant line or secant intersects the circle at exactly 2 points, like this. So a line that intersects a circle at exactly 1 point is called a tangent. Like if you had a circle, like a cup, and if you were to take your pencil and touch the cup, that would be a tangent. The pencil would be a tangent to the circle because it would be connecting to the circle at exactly 1 point. And the point here, that an intersection of the circle and the tangent line, this is called the point of tangency. So there you have it. Okay, so now we have 2 circles over here, circle O and circle P, and it appears that they are not congruent. And just for review, so this would be a chord that's on circle O, or part of circle O, and this is a chord that would be part of circle P, and here's a diameter of circle O because it will go through the center, and here's a diameter of circle P that would go through the center, like this. These are segments, correct? So a diameter is a special chord that goes through the center of the circle. Now, these 2 circles, as you can see, they do not intersect each other. That is, they don't connect with each other in any way. So these are called non-intersecting circles. Now, I could draw a tangent line over here in this particular circle. And let's see if I could draw a tangent line that goes over here like this. So this is a line that's tangent to both of these circles, like this, isn't it? I could also draw a secant line if I wanted to. For example, here's a secant line that goes through both of these circles, like this. And if I wanted to, I could also draw a secant over here, like this, to the first circle, and it's going to be tangent to the second circle, like this. So here it's functioning as a secant, and here it's functioning as a tangent because it's intersecting the second circle, circle P, at only 1 point. Now, I wonder how many tangents like these exist between these 2 circles. In other words, how many lines are there that are tangent to these both circles? Of course, you have infinite number of lines that are tangent to one particular circle, but how many lines are tangent to both of them at the same time? Well, here's one that I drew over here. Well, it looks like there can be another one over here like this, right? So here's another tangent line, a line that's tangent to both of them. Are there any others under? What do you think? Well, I can imagine. You can imagine pencil, right? That's pencil. It's connecting like both of them, like kind of like this. You follow? And let me try to do the best I can. And you can imagine the pencil connecting both of them like this, right? And if that's one like there, there must be another. You could put your pencil kind of like this, right? No, that's not quite right, but if I can imagine, here it is. Correct. That's another. There's at least 4 I can find. Are there any more? I don't know, but that's all I could think of and imagine tangent like this. Anyways, those, at least in these 2 circles, there appear to be 4 tangent lines that they share. Okay, now let's look at these circles over here. Now, these circles, this one over here, they're also tangent, see? But there are tangent like over here. And the smaller circle is said to be in the interior of the bigger circle. So as this circle is tangent as it's in the interior of the bigger circle, and this is the point of tangency. And these 2 circles, in fact, they will only share 1 tangent line between the 2 of them, and that's over here. Can you find any other tangent line? I don't know. If you let me know if you do, but that's all I could think about. How about these circles over here? Now these circles are intersecting circles because they intersect each other. See, they're not tangent circles. They're not like not intersecting circles. These are intersecting circles, and they intersect each other at 2 different points over here. Now these 2 circles over here, the small one and the big one, they also intersect each other, and they intersect each other at only 1 point over here, and they're called tangent circles. But the smaller circle is inside the bigger circle. Previously we saw 2 tangent circles, but the smaller circle was on the outside of the bigger circle, the exterior of the circle. Now here we have 2 intersecting circles over here, and those are the 2 points of intersection like this. Now how many tangents are there over here in this particular scenario? I don't know. Let's see. Alright, so let's see if I could draw some tangents over here. Here's the tangent that's tangent to the line that's tangent to both of them. There's one that looks kind of like it's, on this side, like a mirror image of that one, kind of almost, doesn't it? And how about like maybe to the middle? Oh, that's not going to be tangent though, right? That's secant actually. Just a secant to both of them. Well, that's not what we're looking for. We're looking for all tangents. Well, that's all I could come up with, unless you can come up with more tangents. But that's how I could come up with. So here are 4 different scenarios of how circles can interact with each other. These are circles that do not intersect at all with each other, and we kind of drew some of the tangents there, right? And here the 2 circles that are intersecting, but they intersect at only 1 point right here, and that's called a tangent point, or the tangent circles. And these over here are also tangent circles, but one is in the interior. And these are not tangent, these are intersecting circles. And one last category of circles, which we draw over here. So one last category of circles are what are called concentric circles. Concentric circles are circles that share the same center. So I have drawn over here 3 circles that share the same center. All of them, of course, have different radii. So here's the radii of the little circle P over here, and here's a radii of the middle of the circle P over here. And since they have the same center, they'll all start with the center P over here, and that's the radii of the 3rd circle over there. So these are called concentric circles. And I just labeled them radius 1, radius 2, radius 3. They have the same center, but of course they have different radii. So these are some basic terms that are associated with circles. So as a review, here we go. A circle is a collection of all points. It's a set of all points that are equidistant from a point called the center of a circle, and that's labeled with capital letters typically and denoted like this. And points on the circle are actual part of the circles, and they're labeled with typically also with capital letters. A chord is a segment that connects 2 points that are on the circle, and the distance that a chord is from the center is the perpendicular distance from the center to the chord. And then we talked about the diameter being a special chord that goes to the center, and the diameter is 2 times the radius, right here. So diameter is 2 times the radius, and then we reviewed the formulas for the circumference of a circle, 2 pi r, and the area of a circle, pi r squared. Then I introduced you to the concept of a secant and a tangent. So a secant is a line that intersects the circle at exactly 2 points, and a tangent is a line that intersects a circle at exactly 1 point. The point of intersection of a tangent to the circle is called the point of tangency. Okay, of course, one appreciate that a secant will also include a chord that's part of the circle, right? The CD here, the segment CD, is a chord that's of the circle, but the line itself, this whole line S here, is the secant, right? Okay, that will be true of every secant. So that's a tangent over here. Now, we explored some tangents. We have 2 non-intersecting circles. It appears to me at least that you'll have 4 tangents. And if you have these intersecting circles or tangent circles, it appears to me that you'll have 3 tangent lines. And then if you have circles that are like this is also tangent circles, but one is in the interior of the other circle. It appears to me that you'll have also only 1 tangent lines. And if you have intersecting circles like this, it appears to me that you will have 2 tangent lines. And finally, we finished off. With concentric circle. So concentric circles share the same center. Of course, they'll have different diameters. Inshallah, next time we shall explore more about circles based on this knowledge. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.